I'm CK, and tonight we've got a kit in a little white box. I'm not quite sure what it is. You know what it is better than I do because you've seen the title screen. I forget which one this is, and it doesn't really tell me on the box, and I order so many that I get confused. So we'll see what it is, put it together, and see how fun it is. Hope you enjoy the video. All right, let's see what's in the little box. Digital Electronic Breathing Lamp DIY Kit. It's a digital electronic breathing lamp kit. The LED lamp lights with fixed frequency. The user can set the frequency with different capacitors. It's easy to operate, very suitable for beginning solder. And there's a circuit diagram here. We've got 9-volt DC coming in. A voltage divider here, and a 555 timer, and a couple of LEDs, resistor, a current limiting resistor there, and a transistor there, and another voltage divider going to ground. And that's what it looks like. The 555 breathing lamp works based on the principle of capacitor features, charging and discharging. When the output of the 555 goes high, capacitor C2 is charged, and the voltage of the resistor increases gradually. The base current on the transistor increases gradually too, and the emitter current increases too, according to the BJT amplifying principle, which drives the lamp from weak light to strength light. Okay, that looks fun. So it's a 555 causing it to breathe slowly in and out. And I guess you can change capacitors, but I don't know if they've given you many. Please wear anti-static gloves when installing electronic components. Nope, not going to do that. And here are the steps. Looks pretty straightforward. I don't know if they have an online component to this, but it doesn't much matter. Looks like it's going to be straightforward enough that we won't need much build guidance. Here's the circuit board. Oh no, where's my anti-static gloves? Okay, it's a definitely an inexpensive type circuit board. No through-hole plating, just surface plating, even though the traces and the solder resist seem pretty good on this. Looks like it's got places to put 4 feet. The 555 timer goes here, a couple of capacitors, resistors, the transistor, 3 LEDs, and a connector for 9 volts in. All the values are shown on the circuit board, so we don't technically need this. And we've got a little plastic box, and then we've got a bigger box. I wonder, did they give us an actual, hold on, let me get this box ready for recycling. Did they give us an actual 9-volt power supply? That'd be pretty cool. I can always use more power supplies. They did. Wow. That's nice. It's universal, 100 volt to 240 volt, 50, 60 hertz. Outputs 9 volts at 1 amp. That's pretty nice. Maybe we'll take this apart later too. Maybe. We'll see. And in the little box, a nice little box that we can use for other things later, if we can figure out how to open it. So that's the seam that it'll hinge on, but I can't figure out how to get the, maybe it goes this way. There it goes. So that's the 47Ks, but they gave us an extra one. So that's 3 47Ks, but we only need 2. Here's the 555 timer with a phony Texas Instrument logo on it. It's a knockoff. power connector. That'll be nice to have around. Some big 47. Oh, this is a 220. Okay, so we could do. So they've given us two sets of capacitors. They've given us two 47K, and they've given us two 47K, 47 microfarad, and they've given us two 220 microfarad. That's interesting. We can choose which ones we want. That'll change the timing. This is my 10Ks, and let's see, I've got 3 of them, and I need 1, 2. Again, they gave us an extra one. Extra resistors are always fun. Stock them up. And then got even more resistors, 100Ks. Too many of those. One transistor, though. Transistors cost more than resistors. Oh, I lied. There's 2 transistors. Wow, they gave us extras of everything. Just double checking to make sure these are both the same part number. They are. Then we've got LEDs. Those are beefy LEDs. We'll play with those in a minute or two. Then one disc cap. It's a 104, so a tenth of a microfarad should go near the... There it is. It's kind of far away from the chip. That usually is right next to the chip. And then one little pin header that could go here if you want to give it power from something other than the power prong. And 2 pin headers. Gosh, they gave us duplicates of everything. They were feeling very generous. And here are the little things we'll put at the corner as the feet. So that's it. Looks pretty simple. One thing I'm going to do right first is figure out where I put my solder pad. So let's take a look at one of these LEDs and see how they look using my meter in continuity test mode. Put the black lead on the short leg. Actually, I always get frustrated by that. I'm going to clip it on. See what it does. Yep. Hit the button one too many times. Oh, it's just a white with a little phosphor on top of it to make it more warmer. So that's what we got. So I'll go ahead and get the soldering iron heated up, and we'll start putting this thing together. Resistors first, as always. So we'll start with the 100 ohm. First thing we do always is we say, how close to the body do we have to bend the leads so they go in well? We can leave them like a millimeter on each side, so it doesn't have to go absolutely flat. Now I'm going to solder one of these to see how the circuit board takes solder. Oh, just dandy. Now, since this isn't through hole, you do have to be a little more careful about making sure you get a good connection, since the solder is not wicking down into the hole and wrapping around the lead and making a real good connection. But this is a very inexpensive board. So I'm going to do all the resistors now and not talk much about it, because I just went through everything I generally do talk about with resistors. So it is resistor time. Enjoy everything going on the board really quickly. Oh. And even quicker than that, because I don't need those other 2, I forgot. Okay, so I'm going to jump back in here for a second. I was wondering, because I don't see any 10K resistors here, just 100 ohm. I'm double checking these right now. But yeah, these are all 100 ohm. And that'll just, let's look at the circuit again. Now it definitely wants a 10K between the, as the other side of the divider. Well, I'm going to go to my bench stock and grab a couple of 10K resistors because I don't have them here. Here's a bunch of 10Ks. Because 100 ohm against a 47K would not work well. Let me just put it that way. Lots of good resources online if you want to look up how a 555 timer operates, the different oscillation modes and the flip-flop mode. It's an important chip. It's relatively simple as such things go, but it is ubiquitous. I dare say 80% of the electronics you use, consumer electronics, probably have some iteration of a 555 or some kind of timer in them. So the question is, do we do the 47K or the 220? I mean 47 microfarad or the 220? I think I'm going to go to the 220, which is going to make it a slower flash, kind of like a breathing thing. That feels like it might be more fun. I've got enough rapid flashers around. I know I'm putting this on before I'm putting the chip socket on, but that's because I feel like it tonight. And while I'm in the area, I may as well put the transistor in. Wow, that goes in very nicely. So again, it's a older style board, but it's a very good one. The component positions are good. The solder resist on the background is on the mask is good. There's no solder bleed. Soldered everything? Okay. This is going together really quickly, as you might expect. If we wanted to be faster, we'd use the 10 microfarad. I'm not sure if I'm not bridged here. Let me dig in. Let me dig this a little bit. And just to be sure, I'm pretty sure it's not bridged. I'm going to give it a quick continuity test. And it is not. Always, when you have a meter on your work surface, use it. Use it for whatever. If you're worried about bridging things or worried about whether solder has gotten from one place to another correctly or whatever, just get your meter out. I mean, it's sitting right next to you. You may as well use it. Give you that little extra bit of confidence as you're going along. And I'm sure whoever works at whatever foundry created this chip, they said, what logo? Well, you know what? Go to an atlas and look at the map of the state of Texas and do it kind of like that, but it's not. It's very funny. It's a knockoff trying not to be too much of a knockoff. Now, particularly because I put these two caps in, obviously I can't rest this on the solder pad to do it, but I wouldn't have done that anyway, because what I like to do is just take the circuit board, and I'm holding the socket onto the board with my pinky finger, and I'll solder one leg. Now I'll lift it up and I'll take a look, and as you can see, it's not quite flat. And what I'll do is I'll just heat that solder ball up again while pushing with my index finger. And you might even have heard it. It clicked in and went completely flat. And now it's going to stay. And I can solder the other legs. Make sure that's all good. It is all good. And I'm going to put the diodes on, but first I'm going to recycle the cameras. Now we'll do the LEDs, and long leg is positive, of course. And I'm going to do the same thing with these, because for this one I want to make sure the LEDs are completely flat to the surface. So I'll solder that one leg, then again press down on the LED and snug it onto the board. Do the same for the others. There's that. And what else do we have besides that? We've got the power connector. Now I'm switching to a kind of fatter piece of solder for this because I want to put a lot of solder on these power connector legs, because a power connector takes a lot of mechanical force as you plug and unplug the power connector. And since there are no screws or any other mechanical attachment to this, you're relying on the solder to provide all of the mechanical strength for taking the force of putting the power connector in and out. So you want to give it a good bit of solder. And I just switched to my thicker solder for that, just because then I use less, like I use an 1/8 of an inch of it instead of, say, a 1/4 inch if I use the thinner solder. That's doesn't mean anything at all. Do whatever you want, but just remember you want to put a good bit of solder on things that rely on solder for mechanical. Now we'll push the 555 in. Notch is matching the notch on the circuit board. Now we'll put the little feet on. Yeah, I do have a good, I did a full-scale transistor level scale kit of a 555 timer a while ago, and I posted a link to a good article describing how 555 works. I'll try and find that and relink it in this one. But at this point, we're all done. And as you can see, we ended up with lots of spares that we can use for other projects in the future. Always keep your spares. If you're just starting out, get a box or a drawer or something like that and collect all your spare parts, and in no time at all you're going to have a good collection of spare parts that you can use for bad components, for making up your own circuit boards, all kinds of stuff. Now, I don't know if this is going to reach. Oh, it reaches well. I'm going to turn this light off, and now we'll plug this guy. Let me zoom in a little bit and try and convince the thing to focus. Focus. You focused? Yeah, it's focused. Now we'll plug it in and breathe in. Everything's charging up. And there it goes, breathing out. as the capacitors discharge, then it goes back up. Stays bright for quite a while. And then goes dark again. I'm going to unplug this, turn this light back on, and since this went so quickly, I'm going to go ahead and put the 10 microfarads in so we can see how they do. And we'll do a little desoldering here. I have my desoldering pump over at the other side of the shop, but I don't have the camera set up over there. So, and I don't want to fuss with that right now. And since this is all top mount, I should be able to get all the solder out with the solder sucker. Now, one thing you'll notice I'm doing here with the solder sucker is I'm putting it right on top of my soldering iron tip. I can do that because this is silicon, high temperature silicon rubber, so it can stand the 675 degree Fahrenheit temperature that I use on my iron without burning. And I can make sure I get enough, I can try to get enough negative pressure out of that, what you would call vacuum out of that, to get all the solder out. So I think these might be loose. This pin, I have to bend this lead a little bit. Okay, that one's out. Get these leads bent. I may post, if I remember, I'll post a link to this solder sucker too, because it's my favorite. I've tried a lot of them, and this one works really well. As you can see, that came unsoldered very quickly. Now we'll go ahead and put the 10s in. And these are, I didn't look at the voltage on these. Voltage on these, oh, these are 25 volt, that's good. Where's my solder? Fortunately, I didn't turn the soldering iron off. Now we'll turn the light off again, and we'll see it operate faster. Oh gosh, I was still zoomed in. I hope you saw me desolder stuff. Oh well. On, off, on, caps bleed on, caps bleed out, on. There you go. Now you can see with the 10 microfarad it goes much quicker. Lights back on. So that's it. A fun little kit. Link to it will be in the description as always. And instructional, again, when you read up on a 555 and then look at this very simple circuit, and you can see the traces on the back for how everything is going, and see how changing capacitors makes a difference and what the transistor is doing in all this. It's a good kit. And I hope you enjoyed the video.